In this video, we are going to talk about an ellipse. An ellipse is what's commonly known as an oval, but that is not the geometric term, so we will always be calling it an ellipse. And an ellipse can look two different ways. It can look like it's this way. It's very stretched horizontally. Sometimes our ellipses are stretched vertically. So I'm going to use these two diagrams to kind of talk about our key information for an ellipse. First is the center. Using this as our graphing form for the equation of an ellipse, I want to talk about a couple of major components here. It's an addition problem. It's always an addition problem where both of my x's and my y's are going to be positive, and it's equal to 1. Those are two primary pieces of information I want you to recognize. The center is going to be just like a circle. It's going to be located at HK. The center of an ellipse is very similar to the center of the circle as far as geographically where it's located. It's right in the middle. But these are two new terms, and they are Rx and Ry. R does stand for radius, but we have two different radii when it comes to an ellipse. In a circle, there's just one radius because it's the same distance all the way around. In this case, we have an x radius and we have a y radius. Going up to our diagrams, your x radius is always your horizontal distance from your center to the edge of your ellipse. That's my Rx, my x radius. In the case where my ellipse opens up elongated left to right, that's going to be bigger than my Ry, or my y radius. Oops. That's my x radius. It's opening up horizontal. And your y radius is that vertical distance from the center to the edge of your ellipse. And that's what that looks like here. This lowercase c is not the center. Center is going to be the capital C. The lowercase c is called your focal radius. And we're going to talk a little bit about how to find that in an ellipse, because that has a lot to do with your x radius and your y radius. Mainly, if I want to find my focal radius, it's similar to the Pythagorean theorem. I want to use my x radius and my r or my y radius, but you can see sometimes x radius is bigger than y radius, sometimes y radius is bigger than x radius. Because of that, we have two different situations here. If my x radius is bigger than my y radius, to find c, the focal radius, I'm going to take the square root of the bigger one, x radius, squared, minus the smaller one, my y radius, squared. I'm going to follow the same pattern with my other option, and this is what I do when my y radius is bigger than my x radius. It's ry squared minus rx squared. The reason we do this is we're ensuring that we always have a positive number inside our square root. Okay. F1 and F2, these are what we call our focus, or our foci if I use the plural term. And similarly, there's two different ways that we find this. If Rx is bigger than Ry, so I'm finding this as my C, I am using or utilizing the center. But I have to make an adjustment to it. When Rx is bigger than Ry, I am adjusting my x coordinate, h. So I'm going to take h plus c, comma k, so I'm moving right of the center a certain amount, and h minus c. So if I look up at my diagram, that would be an example like this, and my focus would be here and here. It's always going to be on my x-axis, or my x radius, my major axis. In the case that my y radius is bigger than my x, I'm making that adjustment to my y coordinate. So again, it's going to be plus c and minus c, but one of them is going to be to h, one of them is going to be to k. Let's take a look at this first example. I'm giving you, and in this unit I will always give you your ellipse equations in graphing form. I know it's an ellipse because it's an addition problem and it's equal to 1. So I have this situation. Addition and equals 1. I know it's an ellipse. I can pick my key information. The center is at h, which is -2, comma k, which is +4. Plot it. -2, 4. Rx is always what I'm dividing my x term by. In this case, that's 6. That means from my center, I am going to go to the right 6, 1, 2, 3, 4, 5, 6, and left 6, 1, 2, 3, 4, 5, 6. That's my x radius. And the y radius is 3. So again, from my center, up 3, down 3. Once I have those 3, I have enough to graph my ellipse. Make sure, once again, it's a curve and it looks something like an ellipse. It doesn't have to be perfect. The only 3 other things that I need to see, or 2 other things I need to see graphed, are your 2 foci. I want to see these 2 terms graphed. I can't find them until I know what C is, though. So again, I'm comparing Rx and Ry. I know that my Rx is bigger than my Ry. Right away, that should tell you that when you come down here and you get in your foci, that you're adjusting your x coordinate, because that's the bigger radius. So it's going to be -2 something 4 and -2 minus c, comma 4. So it's just a matter of what am I adding and subtracting here. And that's what I'm doing when I'm finding c. So it's square root, that's what c is going to be equal to, my bigger radius, 6 squared, minus your smaller radius, 3 squared. 36 minus 9, get the answer, take the square root, round c to the nearest tenth. That's 1 decimal place. In this case, I get 5.2. Okay, so again, my center was -2, 4, c is 5.2, and my x radius is bigger than my y radius. That means I'm going to add 5.2 to both my x coordinate and subtract 5.2 from my x coordinate, giving me my 2 focal points. -2 plus 5.2 is 3.2, comma 4. Here's 3.2 is going to be just barely past 3. And then 4 is right here. I just need to label that point. You don't have to put F1. I just need to see you label it. Put the point on the graph. And it should match where you have your ordered pair written. -2 minus 5.2 is -7.2, comma 4. So -7.2 up to 4. I now have my center, my y radius, my x radius, and my 2 foci. Go ahead and try example 2, please. So our first 3 pieces of information, center at 5, -4, x radius of 2, y radius of 5, makes this an elongated vertically ellipse, and I can go ahead and graph that now. Go ahead and make sure you understand how to find C and your foci, plot those, check your work in a second. So finding C, I take my 5 squared minus 2 squared, take the square root of my answer, I get 4.6. That's what I add to my y coordinate because my y radius was bigger than my x radius. It's also what I subtract from my y coordinate, giving me these foci. Last 3 problems, writing the equations of an ellipse, or last 2 problems. Again, I need to identify or locate the center. Here's my kind of sort of diameters, giving me a center of -4, 1. I also want to find my x radius and my y radius. Count it out from my center in my x direction. That's horizontal. 1, 2, 3. In my y direction, vertical. 1, 2, 3, 4, 5, 6. As long as I know those 3 pieces of information, I can go ahead and write my equation. It's an ellipse. So I know it's going to be squared, it's an addition problem, and it's equal to 1. I know that the first one will be my x, the second one will be my y. Just throw in what we found. My x coordinate is -4 at my center, so I do x plus 4. Y coordinate is positive 1, so it's y minus 1. Rx goes under my x term, Ry goes under my y term, and we are set. Go ahead and try that second example there, and be careful because this one opens up the other way, but it doesn't really change anything. Try it. So we hopefully found our center to be at 2, -5, so it's x minus 2 and it's y plus 5. Our x radius at 6 goes under my x minus 2. My y radius of 4 goes under my y plus 5.